All right, welcome Lucas and Wiz live from NeurIPS. How's it going, guys?
Pretty good, man. It's pretty good. A little bit of excitement this morning, but the conference has been fun. Lucas, how are you enjoying?
I'm good. I just got in, so I haven't really gone to the conference yet, but looking forward. I'll be here till Sunday.
Excellent. So welcome in, guys. We have a special session today with a special guest, Lucas Atkins, the CTO and head of research at Arcee AI. They just dropped some new models, the Trinity family of foundation models, and they look pretty dope based on the Trinity manifesto that I was reading through and that we'll go through today. Wiz, what's your take on this? You like them so far? From what you've seen from the Arcee team?
Yeah, do you like it?
Yeah, I mean, I haven't had a lot of time to play with the I would say like the quote unquote real release, which is the mini release. But I have had a chance to talk to Nano, which is so far been a pretty pleasant experience. It's a little bit, it feels like a fun chat bot. Yeah, I can't wait till we get through some of the initial busyness of NeurIPS to have a chance to sit down and really sink my teeth into Mini. But Nano's been fun so far.
Nice. And Lucas, this just came out this week. Is that right?
Yeah, it came out Monday morning. It was not a coincidence that it was the day that NeurIPS started. We very much knew we were going to have a presence here, and we kind of set that as a very hard deadline for ourselves. So,
and Lucas,
Mini came out in what I'd consider a V1 fashion, but we decided we wanted to take a little bit more time with Nano because we can get into this later, but that model in particular is like an alien species. It's a very different configuration, kind of really pushing the limits of sparsity at that scale. So we need a little bit more time with that one.
Okay. And what are you most excited about with this new drop, this release of Mini, of Nano, at least the preview of Mini? What are you most excited about besides the fact that it's happening coincidentally with NeurIPS?
I think there's like external excitement that I have for just getting them out and the wider goal of kind of, having a major open weight player in the US as like kind of the sole mission. But internally, I'm also just excited that, we pre-training and doing this level of work from scratch was very much like a theoretical and apple kind of like in my eye back in February of this year. And then when we kind of really first started dipping our toes into it, really in like April of this year, kind of to see just how far we've come in a very short amount of time. It gives me a lot of pride in the team, and then not just our research team, but like the wider Arcee organization too, who had no reason to trust me that this would be a good idea for the business, but whether naturally or by obligation, they did trust me, and I'm grateful that it's starting to bear fruit.
Amazing. Well, yeah, we've been excited to watch the journey and the evolution of Lucas as well as Arcee. So I'm excited to get into it today. You guys ready to kick this thing off?
Yes, sir.
Okay. All right. So welcome everybody to another AI Makerspace weekly YouTube live event. Today we're covering the Arcee Trinity foundation models. If you have questions along the way, you want to jump in on the discussion, please smash the YouTube live chat or drop a comment in your viewing platform. And with that, let's go ahead and do some introduction to these models. So there was a fantastic manifesto that I believe Lucas was the primary author on that we're going to walk through today. We're going to connect Nano and Mini to the AFM family of models that we covered just a few months back on this channel. And we're going to sort of get you guys up to speed today on the state of the art in American-made, small-ish, but still LLM language models. And we've got even bigger ones coming even from the Arcee team. So this is the state of the art, guys. And live from NeurIPS, we've got the folks that have a hand exactly in building this stuff. So what are you going to get if you stick with us for the next 45, 50 minutes or so? You're going to understand what these Trinity models are all about, how the lessons learned from building the AFM foundation models have led to this new open source release, these open weight models that are the Trinity models. You're going to understand what makes them different and what that state-of-the-art training pipeline looks like today, what the state-of-the-art architecture looks like today, how we are sort of iterating as we go, and why, importantly, and this might be the most important thing to take away today, why it's so important to not only own the weights, but to own the entire training pipeline, preparing for tomorrow on the horizon. So we're going to talk about Trinity. We're going to connect it to the AFM models, and then we'll have time for your questions if you're not smashing the chat along the way. And LLMs from scratch are no joke. These things are massive undertakings, and this is some of the most interesting stuff when we can really get into the deets of how these things work and how they can then be used and integrated into our higher level application. So let's introduce this. Trinity, open weights. They've got a production API that you can use directly, access to tools, can provide structured outputs. 2 sizes came out. And kind of the big headline on this is it's the MOE that's built end-to-end in the US, open weights, full control for you, the developers, came out this week. So let's read through some of the key points and let's start the discussion on why this model. Over the last year, anyone who cares about open weight language models has been watching the Chinese labs. That is DeepSeek, Qwen, and others. They kind of have been defining what the state-of-the-art open MOE looks like. In the US, most of the action has been centered on polishing other people's checkpoints. Love that one. Shots fired. Let's go. We want to add something that has been missing in the picture: a serious open weight model family trained end to end in America by an American company with weights that businesses and developers can actually own. Welcome to Trinity. So one of the things that's important to understand here, and we'll kind of start with it and we'll come back to it in the end, is like sort of why we need to train from scratch. As the manifesto tells us, we decided to own pre-training. That wasn't always the case. For a while, the strategy was take a strong open base model, post-train it, wire it up to tools, do some retrieval, augmentation, and ship it. That can take it very far. And that's great, but it's not the whole story. There's a few bottlenecks that started to occur, a few pressures, as the manifesto put it. Number one, ceilings on certain workloads. On some high stakes use cases, we kept iterating on post-training and could see clear diminishing returns. Failure patterns pointed back to missing capabilities in the foundation, not to tuning mistakes. They go on to point out jurisdictional safety. This one's pretty straightforward. Enterprise buyers are like, yo, where's the data that you put into this? What exactly was it? Which licenses are being used on it? I don't want to get in trouble later. We fine-tune a model with unknown data provenance was no longer acceptable in 2025, certainly for security and compliance people. So that one's quite straightforward. But perhaps one of the most interesting things is this idea of the long-term product vision. We strongly believe, the Arcee team here and Lucas, that within 2 years, all meaningful AI applications will look like systems that grow and learn inside the environments where their users interact with them, that grow and learn inside the environments where their users interact with them. Those systems will adapt their own training loops and build and train directly from live usage. To build that kind of software, you need control over the weights and the training pipeline, not just the fine tuning, the instruction, the post-training layers. Well, caveat, we still have open source models from other people. We just feel like the future is really owning the foundation. And so we need to train our own foundation. So first discussion series. Boys, let's bring you back up here today. First off, Lucas, on these ceilings, man, can you tell us a little bit more about this? Like, what types of use cases were you really seeing these diminishing returns on? And what should people watch out for when they're just pulling models off the shelf in the future?
I think that it's important to note that that ceiling for an individual developer is actually quite high. So if you are a developer who is making some kind of AI application and you want to fine tune a smaller 6B, 8B, even 14B model to be really good at whatever that task is, say it's like invoice processing or something like that, and so that you can like cut down your costs, own the whole loop. That ceiling is very high. You can get those models to do some really, really impressive things. In that blog, I'm mostly speaking to Art's experience with like large scale enterprise contracts. And the reason I bring that up is because especially when you're working with like very large enterprises, Fortune 500, Fortune 100, there is a very long procurement process to like sign that deal once the initial problem has been stated and you're discussing solutions to it, and how maybe an Arcee, customizable model could help. And then the actual engagement also takes quite a while because you're dealing with many different teams, many different people of varying levels of AI intuition, and so what ends up happening there is you start a project say in January, but it doesn't complete until September, and by that time you're 3 generations of models behind where you started, and so it kind of creates 2 things. You either need to really kind of constantly be trying to, you're hitting that ceiling several times compared to like kind of what's open at that time or available between like from OpenAI or others, or you have to hope that other kind of like as incrementally improving versions of the open models that you're training on also are released, and neither of those is guaranteed. So this is mostly like reducing the number of variables, making ourselves kind of like fully in control of that. And if we need a better model, we can train it, as opposed to kind of having the foundation of our business be hoping that others release open weight models, which I think is in the long term a poor business move.
Yeah, quite hard to manage that risk. So really the diminishing returns are almost like the diminishing returns on other LLMs. Yeah. That you sort of have to just kind of balance the risk of. I mean, Wiz, you certainly see this all over the work that you do, and even in the work that we do at AI Makerspace. It's like, I tell students all the time, don't learn it now if you're not going to use it now, because you should just learn it in 6 months or in 9 months or in 12 months. But enterprise doesn't work that way. Some things just take 6 or 9 or 12 months. And that sort of tug and pull between enterprise and AI, so important.
Yeah, I think there's there's a portion of it too that's really prevalent, which is like we're still seeing a lot of the models being built as generalists, right? So one of the researchers that I get to work with says a lot like this is a 3rd phase of LLMs, right? So we have generalists that can specialize. I think that this, having your own base to start with, being very intimately familiar with it, being very familiar with the whole training pipeline does let you build specialists. And a lot of the times companies aren't doing 50 things. They're doing 2 or 3 things that are of critical importance, right? And so it makes sense to see people move more toward, well, bespoke models with time should be sufficient. We know it's going to be good at these tasks versus we know it's going to be good, kind of good at everything, and we hope we can make it really great at 2 tasks. I think Arcee has always kind of been a big embracer of this idea of specialized AI, or whatever marketing term you want to apply to it, right? Like, so this is, it feels from the outside like a natural extension to the plan.
Yeah. And so maybe another way to balance these risks of diminishing returns is through specialization. And I think like perhaps a specialized model has a longer shelf life than a non-specialized model moving forward. And I think maybe, Lucas, one of the things that you guys sort of started with SLMs, we're going to build SLMs, and maybe it's like we're going to enable people to build SLMs, is sort of this kind of phase. So as we sort of look more into less into the kind of boring change management enterprise stuff and more into like the details of the tech here, when you think about these systems of the future, we kind of often talk about with our students and on this channel, the sort of the data is the gold that you're generating with your app as your users use it, as you feed it back in, and sort of that's how you become this thing that can't just be outdone by the next model through this specialization and real connection to the world, or let's say to your environment. Can you tell us a little bit about, like, just bring us into you guys' world a little bit, model builders here. Is this something where we think about like all systems are going to be adaptable and learning and growing on their own? Is this something that is kind of well known in the LLM, sort of builder community now? How long has it been that way? We've seen a lot of RL VR this year, and like for folks that are kind of just using LLMs to build applications, this isn't something that people are often thinking about, but maybe it should be. So tell us a little bit about your vision and why your belief is the way it is.
I think that one of the things that was kind of a big cliche going into 2025, but we were still in 2024, was 2025 is going to be the year of agents, and there was kind of this high degree of optimism that long horizon, multi-hour agents were going to start really kind of being ubiquitous towards the end of this year. And while we definitely have made really big improvements in that space, they have not been general agents. And let me phrase it that way, is this way, in that I think the first thing that I would consider kind of a widely agreed upon agent that like actually did the thing it said it was going to better than anything else at the time was deep research from OpenAI. I think that was like at least for me, that was one of those where, okay, this is extremely impressive. And they weren't the first to try deep research. Google had done something similar earlier, and even others who kind of had applications for doing that, kind of your third-party developers or businesses. They were using a general model from OpenAI's API or Anthropic's API, giving it access to some tools and putting it in like a search loop, and then at the end having it aggregate all of the information. Whereas deep research was a specific version of O3 that they built environments and rewards around to reward and amplify its ability to not just do long horizon deep research tasks, but also do them in a way that delivered on what the user was actually looking for. And since then, Claude Code has also become extremely good. Codex is getting lovely. You're seeing a lot of these longer horizon agents be specifically towards code, as it's one of the most kind of like revenue producing streams and useful, and it's also very, very rewardable, very verifiable, so it works well with RL. So the vision here is, as I kind of play the tape out over the next couple of years, and I do like to say that my fog of war in this industry is about 6 months. I can give you a pretty decent that I would say is a decent intuition for what we might see over the next 6 months.
Yeah.
Who says? But if I'm playing the tape out, I think that similar to deep research, similar to Codex and Claude and Even, OpenAI, you've seen it with agent mode, and now you're starting to see it in some of Google's applications, is those apps that have that kind of aha moment for users of, oh, this is what was promised, or what was promised is being delivered on, are going to be those applications that have a model inside that was trained specifically in the very environment that it is being used with users, and then kind of continuing to improve over time as it gets more and more real world feedback. So this is less of a continual learning manifesto, as I do think that term, much like agents, has a very wide definition.
Sure.
But I do think that, I think that one of the truly ways you'll be able to differentiate yourself outside of kind of the monoliths that are OpenAI, Anthropic, and Google is going to be owning your model layer, making sure that you're able to fine tune and train towards exactly what your task is, do that cheaply, and with a high degree of regularity.
And this is something that we've had language for in the enterprise, though it's a rather stodgy word, right, or phrase, which is data flywheel, right? So it's this idea of, there's this natural evolution from what's a very stiff process, moving toward this idea of we should have these agents, or we should have the LLM systems that power these agents live in the environment that they're in and receive feedback from the environment that they're in. I think this year has given us much better and much clearer language to describe what we would previously rather memely call the data flywheel, where
the feedback loop.
Exactly. The virtuous cycle, right?
That's right. Yeah, that's sort of the data is the gold. I mean, like Aaron comments in the chat here, this is sort of I don't know if it's a false dichotomy or not, guys. What do you think? Because it seems to me that if it lives in the environment and that the model's living it, that is its context. So this idea that, context management is more important than model building, I don't know, reading your manifesto, Lucas, it started to make me think a little bit about, a little bit of model fine tuning is context management, especially if we play the tape out a couple of years. How do you think about this?
I mean, for the most part, I think I've never thought of this before, so I might tear down my own opinion later upon reflection. But fine tuning, at least in the SFT world, where we're basically user or instruction answer pairs, very much was often done at an enterprise and even a developer level for exactly context management. It was how can I get this model to behave in this certain way every time without me having to instruct it and give it a 20,000 token system prompt that often fall apart with models of this size. And SFT is still a tremendously powerful tool. It is by no means being replaced by RL, but I do think RL and SFT play super nicely together. So I don't know. I mean, we have some initial plans for exactly how we want to enable this at a product level, beyond just making the models available for people to do this kind of training and fine tuning on, but nothing to announce on that just yet. But there is a copious number of companies who are out there building kind of open source reinforcement learning tools. I know a lot of companies are starting to build out RL as a service platforms. And I think that is going to be an area of intense competition over the next couple of years.
Yeah, Wiz, I'm kind of reminded, it's should I use RAG or fine tuning? It's should I do context management or fine tuning, Yeah,
I mean, it's always been the same question, which is how do I make the system that I have better at the thing that it's supposed to be good at, right? And we're once again talking about, both of these things have some net impact on capability, right? Building better models very obviously leads to better systems. Building better systems very obviously leads to better systems. But I think the idea is that we should be doing some balance of these things. We should never exist fully in a vacuum and only focus on one. Now, that's not to say that every company has the luxury to focus on both, and maybe this means that you pick the most impactful for a period of time. But I think when it comes to a company that's in the model building space, very obviously the tools you're going to reach for involve fiddling with the model weights, right? There's no reason to not in that situation, especially if, as we see on the screen, this quote, right? Especially if you have a system that's running in the context that it's going to be running in. I mean, it's real easy to bake everything into the model itself in that situation, and still pay attention to the rest of the context management or context engineering.
I do think that over time, what's going to become very important is you already have a lot of like agent trace, like a lot of agent management tooling to like for observability, see what happened. But I think what's going to become even more important is like identifying where, if there is an issue or a bug or even some kind of possible improvement to the system, where does it need to be made, right? If you're doing the model and the product and the platform itself and hosting all of them, even just in the week leading up to launch, while we were kind of getting some of our final checkpoints and sending them to our inference partners, whenever something would be anomalous, either in our app or via the API, deducing whether that was like a model problem, an inference problem, meaning some misconfiguration with a provider, or like something we were doing once we got that from the API in our app, was really tricky. And the key there is like to remove as many variables as possible, right? Like hit it very clean without any, injected prompts, and run it locally yourself and see if you can it's kind of back to old school debugging, but it was a very interesting problem that I was kind of one of the few people that was uniquely able to help solve, because everyone else at the company is like super involved in the product. Then I have my research team super involved in the models, and then the provider is super involved in just getting that working at a high level. I was one of the few people that had insights into all three and could kind of be like, no, that's this person's fault. And it was really interesting. It was an interesting predicament.
Yeah, it's almost like ChatGPT in the beginning, like the thumbs up, thumbs down, wasn't like direct to the model. It was sort of at the product layer. It was sort of getting user feedback from people using the model, like out in the world. And there was sort of an environment that was being created around the LM. So yeah, there's a lot of interesting sort of ways to think about optimizing. I mean, just last point on this product vision piece, Lucas, like I wonder, of all the levers you can pull in pre-training and post-training, I mean, what are some of the highest leverage layers? What are some of the highest leverage levers that you think like builders out there should think about pulling? Like, let's stick to people not necessarily building models, but building systems. What have you learned in this journey, especially since February, that you'd recommend people starting to think about if they can build systems, but maybe they're not that into training models yet?
Yeah, I mean, data, regardless of where you are, is still by and large like the number one impact per improvement part of the whole stack. As far as data, any kind of work you do on data, whether it's analyzing user data or analyzing pre-training data, any experiment is going to have some kind of net benefit, because if you're doing an ablation and the data you entered for some new experiment made the model worse, well, then don't do that and you'll make your model better, or vice versa. If it makes it better, do add that and it will make your model better. So that's one of the few areas in just like research as a whole where it's very high impact, whereas a lot of research is 95% of it never kind of sees the light of day in terms of like going into the model. But what I will say for maybe people watching this channel and kind of taking these learnings and doing them in a more accessible way, I think that like the prompt optimization kind of that we're getting into with things like DSPy out of Stanford, which is a lovely framework for kind of instead of doing optimization over a model's weights, you're kind of doing it over your agent harness itself. Like, what prompts are you feeding the model? And then like they just integrated a newer kind of more cutting edge optimizer for that called JEPA. So it's very reminiscent of RL, where you set an evaluation, how you want the model to do on it. You know, it will get a baseline, and then using kind of like a reflection model, it will kind of iteratively add and tweak a system prompt to get it as performant as possible on that task. Which leads me to having your own internal evaluations is going to be extremely important. And I don't mean that so much like, yes, downstream performance stuff is good, like academic benchmarks. How does it do on, you know, graduate level scientific reasoning? Like, that's cool. But one of the things that it's kind of a double-edged sword, because while we might have spent a lot of time in post-training making sure that it did well on those kind of questions, because we knew that that was an important benchmark that it would be judged against with its peers, those are not the kind of questions that our users are asking it every single day. And I would argue, if you are doing graduate level scientific reasoning with an LLM's help, don't use a 26B model, you know? And so we're now, luckily we have a lovely head of product, Sam, who has a tremendous amount of experience doing like user and platform level evaluations to ensure that like you're building out a suite of internal evals that closely match with users, you know, the things your model's actually being used for in production. But having, and another thing to speak to there is, and this isn't just with LLMs, this has been in software for decades. This is good practice, not just in software, but in anything that's serving customers, is ensuring that your evals closely align with what your users are saying. So if you have internal evals that have your model at like 95% performance, it's doing great, but then your users come back and there's only like a 60% satisfaction rate. That's not a problem with your users. You know, you can't just say, well, you're using it wrong. Our things say it's great. No, that's a problem with your eval. So being very, very, very particular and discerning with what you consider to be a good model. And that also helps users, as not just like open weight models from us and other players keep releasing, but also like kind of your frontier closed models. As we reach this level of saturation, right? Like Gemini 3 in particular is a good example of this, where it came out and the step change in benchmark performance was massive. But even me, I was struggling to find a suite of prompts that would help me decide actually something I would use over like Claude or Codex. And that's only going to get worse as these models become more and more capable. So it really is going to be what is your personal preference? What is meaningful for your users in your day-to-day? And then just always being better, right? It's progress, not perfection. You're never going to be perfect. We certainly aren't. There's a lot of things I'm looking forward to improving in the Trinity models, but at least, you know, getting stuff out there, trial by fire, getting real human feedback is extremely important.
Okay, so be data-centric, optimize your prompts, use internal evals, really focus on the humans using your product. Anything we missed, Wiz? We got to keep moving here.
No, I mean, it's very well said. I think the most fun part of modern, you know, LLMs, if we can call the kind of new class of frontier models that, just to meme a little bit, is that like we went from the beginning where we would do like these vibe checks just to see like where they obviously failed, right? And then we would know what the model is just trash at. And then we went through a period of time where we focused on, okay, what do the numbies say, right? Like how big is the chart? And now we're right back to vibe checks, but instead of obvious failure points, just like, do I literally like the vibe of this model that's assuredly competent enough for most of the tasks I'm going to use it for? Even open source models at this point are getting to that stage where if you've used enough 30 billion parameter models, you kind of understand what they're capable of, And now you're trying to choose the one that best meshes with whatever workflows you have set up. And I think that's a very, very cool space to exist in.
All right. Yeah, love it. Great insights as always, guys. Let's go ahead and introduce the next piece of this, AFM, the models before the models. So we covered AFM on this channel a while ago. It wasn't actually that long ago. The official release was in July. AFM 4.5 billion, the Arcee foundation models, that family used a decoder-only transformer model. This was a classic style, and they made key modifications, including grouped query attention, ReLU squared activation functions, improving sparsifications without compromising performance. And as they told us in the Trinity manifesto, AFM 4.5b was our "can we do this at all" experiment. Namely, can we stand up large-scale data pipelines and training pipelines? Can we validate that careful, considered data curation gives clean scaling? And can we get some real experience with truly end-to-end training? At that time, tremendous effort was put towards excluding copyrighted material and books. Everything that was unclear, it was out. Figure out what not to include. Fewer hallucinations, better accuracy, more trust, and more security for those compliance officers. We also saw multilingual performance that was quite good. This was, again, in the 4.5 billion parameter model. And adding additional languages was quite easy. So that model used 8 trillion tokens, including 6.5 trillion for pre-training and 1.5 trillion for mid-training. And we talked about mid-training and the sort of annealing process and the kind of getting ready for post-training that provided. And specifically, this was data that was emphasizing reasoning and code gen, totally aligning with things that continue to be emphasized today, agentic things. After pre-training, there was the supervised fine-tuning, the RLVR, and RL with human preference that were kind of on top of it. And we talked a lot about that. Post-RL, they use merge kit to merge different checkpoints to smooth out inconsistencies, and even followed with an additional RL technique called KTO. And the AFM 4.5b model, the TLDR on this is that it worked. Gave us a solid base of training and infrastructure practices and showed us where to focus on capability improvements. Those lessons led directly to Trinity. So Trinity was released, and Trinity is not 4.5b, but Trinity comes in 2 sizes, the 6 billion parameter and the 26 billion parameter. Now, note, these are MOE models, mixture of experts models. And that's pretty cool because I don't believe that AFM 4.5b was. So that was adopted. And super interestingly, originally we thought of Nano and Mini strictly as training wheels for Trinity Large, but the models proved stronger than expected. Mini, the bigger one, is a compact reasoning model designed for agents, tools, and multi-step workloads. Its quality sits close to current instruct models. They got some benches you can check out in the blog. The Nano Preview is an experimental model for low resource chat and instruction following. You know, we might be able to say we can use this in all kinds of places, including out on the edge. These are some of the most cost-efficient models in the world. Okay, so Lucas, I'd love for you to comment on kind of how you decided on model sizes here. Like, so you built 4.5b, and then like, where did you go from there? You know, like, what sizes do we build? and you ended up on 6B and 26B. Are you just sort of taking cues from industry, or your own intuition and your own kind of steady improvement?
It initially comes down to, well, as I said in the blog, is we knew we wanted to go bigger. It was very interesting. Like as soon as we released a powerful small one, the immediate bit of feedback and questions we got from developers, customers, investors, like everyone is like, can you go really big? And I think that we wanted to challenge ourselves with that of training like a large scale, what we would consider something that is a real shot at having kind of frontier level performance in the US. But you have to prove that you can do that. It's not as simple as just like tweak a few numbers in your training pipeline, make it 400B and then let it rip. Especially with the kind of industry standard mixture of experts models that are out there now. They are tremendously inference efficient. So after you're done training, especially in RL, like they're awesome because you can do a lot more rollouts. You can do a lot more steps than you otherwise would for the same compute budget with like a dense model. But with that extreme benefit comes a lot of complexity. As you scale up to more and more experts, the amount of information that you are having to send to each expert across however many nodes and GPUs you're training on becomes really complex, making sure that you're balancing that correctly so that no individual expert is being served or trained more than others. And all of that led us to, okay, so if we want to train a really big model, what are the sizes that are going to help us ensure that we kind of, at a lower cost, less risky run, get us the information we need to inform the big one? And so we knew that. Then we knew, okay, well, what size for the amount of money we want to spend do we think we could train on? Up with roughly like 30B 3A, which we also liked because we'd seen sizes from like Quinn and OpenAI in that realm. So we knew that they could be performant. And then it really just kind of comes down to starting ablations, doing runs, seeing how many tokens per second you're getting per GPU in that training. And then slowly but surely kind of optimizing all the little, the hidden size of the model, how many layers you're using, how many, what is the breakdown of each expert until, how many experts you have per token. And then eventually through kind of checking off all those variables, you end up at a size. And so it was 26, 3B was actually the only one we were going to do at first. And we really liked that size. And that one started training first. And then a couple weeks into training, we had some very fun results with a 6B total 1 billion active. There'd been some releases in the last year that showed with smaller models, giving them much a bigger depth, meaning more layers, can solve for some of the drawbacks of smaller models. And so we said, screw it. We have some extra compute lying around. Let's do a 6B model, with 56 layers, which is almost twice as much as the number of layers that we have in the 26B, and is also roughly the number of layers that our Trinity large model has. And we wanted to see kind of what that would do, especially once you go for like sparsity, right? Where we have, again, 128 experts, 8 active per token. And so very much Trinity Mini, the one we released kind of that I would call, I'm happy with the V1 variant of, was, can we prove out what we want to do for a big run? And can we give ourselves the confidence that we could do it? And then the 6B was, hey, this is kind of cool. Let's give this a shot. But because of that, and the reason it came out in preview is it's not a one-to-one training dynamic compared to the 26B. It's like a very different beast. And as such, we are still figuring out where that model best fits and how exactly to make best use of it. And all of our efforts were in like Mini has to be good. So yeah, that's kind of how we came up with the sizes. 26B was more scientific and methodical, and 6B was very much just vibes.
Yeah. So like, how long did it take you to train the 6B?
Both took a month. Both of them took about a month. I think the 6B was a little bit faster, but we also took a little bit more time with that one because we were kind of, for context extension, we were doing a lot of new things here with how we were doing context and managing attention. And so we ended up doing more ablations on the 6B while we had the cluster. So, 2 weeks is probably what actually would have taken had we not gotten that reservation for a month.
That's a great segue. Okay, so I want to introduce some of the aspects of the architecture and training right now, and then we'll have time to discuss these as well, including, first up, attention. So I'll see you guys back in just a moment. So let's talk a little bit about the architecture, guys. He mentioned some of the things they did with attention. And their overall architecture that they're using here, they're referring to as Arcee Foundation MOE, I suppose, AFM OE, which integrates leading global architecture advances such as gated attention and muon with a clean US controlled data pipeline. This is an optimizer. This, of course, has to do with attention, but that's not the only attention thing that they did. They used group query attention that we saw in AFM 4.5b to reduce memory bandwidth. They applied an RSM norm to the queries and keys, call it QK norm, to stabilize training. They also used this gated attention, specifically the G1 configuration from the Quen paper just mentioned. After the scaled dot product attention, the output was element-wise gated, before the output projection, giving the model a learned ability to modulate attention outputs per position. So many good details in here, but it's not done yet. Finally, we adopted a local/global attention pattern at a 3-to-1 ratio. 3 local attention layers with rotary positional embeddings are followed by 1 global attention layer without positional embeddings. Nope. This reduces compute on long sequences while preserving at the same time the model's ability to reason over distant context. So reasoning over long context efficiently. Now, there's a couple other things I want to point out. I'm not going to point out everything. We encourage you to go into the blog, but a couple more things worth mentioning. One is the MOE layers. MOE layers followed a deep-seek MOE design, fine-grained experts with a shared expert, as Lucas has already mentioned. 128 total routed experts, 8 active per token, alongside 1 shared expert that is always active. And as he mentioned, talking about sparsity a little bit, the first 2 layers of the model are dense rather than sparse, providing this shared representational foundation before specialization begins. Very cool. And then for routing to the experts, they used the sigmoid routing as introduced in DeepSeek v3. They also adopted the aux loss-free load balancing scheme. And overall, this eliminates the need for auxiliary load balancing losses that can distort the training objective. Data, not 8 trillion like in 4.5b, but 10 trillion. 3 phases with progressively higher quality in STEM concentration. I'm reading sort of reasoning and code gen there. And then finally, context extension, I want to mention, we only expanded the global attention layers. Remember, local global attention? During context extension, allowing the models to learn extended sequence lengths very quickly. So, okay, guys, there's a lot of stuff that you did in the attention piece. Like, how can you break this down for everybody out there and like why this stuff matters and where it's coming from? And is this sort of just rapidly being figured out by the industry, or is this stuff we should all know already?
Oh, I wouldn't say that any of this is like required reading unless you are interested in kind of doing one of these from scratch. So it is always important to understand the architecture that you are building with, right? If you're post-training, especially the big one that people should definitely know is Muon. We did use the Muon optimizer, which means that if you are going to be doing any like post-training on these models, that you definitely want to use Muon as well. Atom could likely work and will do fine, but Muon is great, and every kind of fine-tuning library that's out there right now supports a variant of Atom, of which there.
And maybe you could just tell everybody what Muon is real quick. So this is from the Quen paper.
Yeah. Well, no, Muon. So Muon come out of Quen. Gated attention was from Quen, but
Gated
Muon
attention, okay.
Was made by a guy named Keller Jordan, and he. I believe it started out of kind of like these nano GPT speedruns of how can we, get the fastest training to a specific benchmark number as quickly as possible. And for a long time, Atom, and in many ways still does, own the industry. It's a kind of old school optimizer that is basically the algorithm that is managing and updating the weights of your model after computing the kind of cross entropy loss, or just the next token prediction loss in pre-training. Muon's a newer kind of borrows from a bunch of different optimizers that have come up over the last couple of years, notably one called Shampoo, and it's like a momentum-based optimizer, and has shown Kimi and I believe GLM also used it as well. And there's good reason to believe that OpenAI and Anthropic and Google are using variants of stuff like that. Keller was hired by OpenAI, so
well, there you go. So a true best practice there.
We think so, yeah.
Okay. And then, so in terms of attention, then gated attention was top level mentioned. What other best practices are worth picking up on here for people? Group query attention is something that we saw in the last model as well.
Yeah, I think the way we approached the architecture here was we could have just taken DeepSeek's architecture and ran with that. You see a lot of people doing that. Mistral's most recent model, Mistral Large, is very much uses DeepSeek's architecture, and so did Kimi, which is they just scaled that up, and it works. There's a reason DeepSeek is the king. They did a ton of work on that. The reason we chose to differentiate ourselves is, one, we wanted to again challenge ourselves, and two is we're taking a lot of proven recipes from a bunch of different papers and kind of work we've done ourselves, and kind of Lego matching them together because we had the opportunity to. And so the gated attention from Quen is amazing and does a really great job of allowing the model to better score the importance of the token in its context. And then the hybrid attention, which was actually something that had been done before, but we saw it first in GPT-OSS, where you're doing local global, is an attempt to give the model different tools to pay attention to the immediate window that it's working in, which like 1,000 tokens, ensuring that it's attending tightly to that, while also giving it the tools that it needs to manage its larger 128K sequence length. And this also luckily allowed us to extend the context really, really easily. These models are really great at memory efficiency over long context because of these choices, and it also it generalized to long context really, really well. I think we only did about 40 billion tokens of long context extension, and it was already doing stellar in our tests. So it was nice find.
Yeah. So, Wiz, we're going to cover like memory soon on this channel. I was struck by like kind of the global local, and then this idea of long context in the age of context engineering, context management, and everybody's to avoid context rot. And it's like, I don't know, like how important is long context today? Wiz, what are your thoughts on this? And then we'll get Lucas's thoughts as well before we head into the last little discussion here.
I want to say one thing on the previous slide, because I pre-cleared the half joke with Lucas, which is that, so Arcee has had merge kit forever. They've been a big fan of model merging, And this feels like a Frankenmerge of all of the best architectures that we've seen from the last year.
A real hack job, these guys.
Yeah. So there's this really programmatic way to do something like this, which is called neural architecture search, right? And part of what you do is you find the right Lego blocks. And this is the kinds of architectures that you might come up with, which are non-standard, they're still intuitive. I mean, it makes sense why each component was selected, right? But it really shows that Arcee is not just looking to make a good model right this moment, right? They're dedicated to making the best models over time. And I think this is the amount of care and exploration that needs to occur, especially right now, in order to get that cocktail. And tying it together to long context, you'll notice that every model that's coming out recently has some concession to, we're going to have to shove many, many thousands or tens of thousands of tokens through this thing. And so we can't have it be bad at understanding those long distance relationships. And we also can't have it being slow as we continue to scale the amount of tokens we're pushing through the machine. And how important is long context? Listen, long context is something that's always going to be talked about, especially from an academic sense, as being incredibly important. There are a lot of use cases where the context window could be, back in the day, it could be in 4K range, and you're still going to get everything you need done with that model, right? Like it's not like every use case needs it, but as we make longer context more efficient, right? Because when we talked about this moons ago, right? RAG versus long context.
Yeah.
A lot of what we said boiled down to long context is extraordinarily expensive, right? And highly prone to errors. So the more you drive cost down for long context, the more you drive cost down through proxy by having reduced errors, the more and more we can actually lean on long context, as a viable alternative to something like RAG or search-based methods. So it's very important, and it's going to continue to become more important as we make more efficient and better long context systems, right? If you could dump the whole code base in, and the model could understand it all, and it could be not 67,000 times more expensive to do that than a search-based method, then why wouldn't you, right? And so driving toward that ultimate goal is still, you love to see it, and it is only going to become more and more important.
Yeah. So Lucas, I want to end on something different, but I mean, it's probably simple for you guys, right? Your customers are probably like, we want bigger models. We want longer context. We want it all. Like, I don't know. Is that kind of what drives some of the decisions on long context for you? Or is there something else, like maybe 30 seconds?
I mean, it's mostly that we also knew that for the large one, we were going to need to have a pretty sizable context length, just for when you're really pushing stuff for code agents, like the amount of context that they take up just searching for the right files to edit is huge. But it was also like, because we knew we wanted these to be reasoning models, like it might use 6,000 tokens of reasoning before it even answers. It luckily, through the way we did RL, it actually doesn't. It's pretty small thinking, and for its speed, it's barely noticeable. But yeah, once you're filling up the context with also the model's own thoughts, having something up there, at least at like 64K, is pretty important.
And this is like a really key difference, right? That when we started talking about long context, we kind of always associated with it with, I'm going to use the TLA here, right? So which is input sequence length, right? Or ISL. Like this is what we were obsessed with, right? How much shit can we pile in the context window before we click go? And as reasoning models have proliferated, we are much more concerned with additionally caring about high output sequence length, right? Or OSL. And I think this is totally new to people, that it's the same window on either side of the model, right? So
it's always confusing to people. Yeah.
can take in a lot, that can also generate a lot. We need a big freaking window.
Oh yeah, exactly. Okay, so Lucas, one final question. I was struck by Wiz's comments on the Franken merge idea. Like, it seems like you guys are, because you called out DeepSeek as the GOAT. Okay, but it seems like part of the argument there was, and of course the Chinese GOAT, let's say. Okay, like the argument there was they're kind of constrained on resources, so they have to do like creative things.
Yeah.
And it seems to me now that you guys are quite constrained on resources and you're doing quite creative things. And DeepSeek maybe is less constrained than ever before. I don't know, but it certainly seems like they're just, in the headlines whenever they want to be. Do you have any comments on how we can, expect to see the creativity from constraint coming from you and the team there? Or how would you like us to kind of think about you guys as coming up in the game? Because that's how I think about you.
Well, no,
right
I mean,
now.
you're absolutely right. I think one of the main things it was important for us is we never raised as like a foundation model training company. So like we didn't have endless dollars to throw at a problem. Like we knew how much we were willing to spend to do this, and we have to stay within that. So doing it at a cost efficiency is like super important, and working backwards from that does necessitate creativity. And so I do think that we will continue to, as we iterate and improve and train more models, doing it in a cost efficient way, not just for us but for the people using them, is going to be extremely important. And one very interesting note on that is when we were designing the shape of Large, our bigger model, we were using Chemi and DeepSeek and Quen and GLM, their shapes, number of experts, hidden dimensions, like we were using them as a baseline. And what we found was we're training on Blackwell for the big one. And some of the choices they make are not optimal for Blackwell. They're optimal for the machines they have, largely H800s. So it was interesting where we had to have this internal kind of moment where we went, we were trying to optimize so much for their shape because we assumed that was like the best for downstream performance. When what we found was like, no, they optimized for that shape because it was the best for the hardware they have, and we have to do the same. So I think as Blackwell and these newer generations of chips make their way around the globe and to other players like Arcee, the shape of these models is going to be changing quite a lot.
I think I think you've heard about that before, Wiz. Have you?
Yeah, Blackwell.
Yeah, you heard it.
We're seeing companies designing for hardware. I think as well we're seeing chip manufacturers working very closely with model builders in order to facilitate something called co-design in the ecosystem, which is where the models drive the chips, drive the models, drive the chips. So.
A flywheel, if you will. Okay. Yeah. All right. Okay, so we got Trinity Nano, we got Trinity Mini, we got Trinity Large coming soon. This is a serious open weight model family trained end-to-end in America by an American company with weights that businesses and developers can actually own. Guys, I know we're out of time here, but one quick question to answer from the chat. Do you subscribe to the 140K limit for context before performance will degrade? I believe this is maybe from the context rot thing. Just true.
What this is speaking to is kind of the theory that like even if you have a million context window, a million token context window, the actual usable amount that the model can fully attend to is roughly 140K. I don't know. I've never heard that number being. I don't think it's a universal rule. So my initial answer would be no. But I do think that what we found is that in order to do really well at 128K context, we had to train at 256. And so our total like performance level, like usable context window was roughly half of what we trained for. So I do think that there absolutely is something to be said that the window you are given might not necessarily be the most optimal window for you to use, But again, that gets set to like internal evals and measuring that, because it won't be universal for model family. It'll definitely be dependent on the decisions they made, the choices they made, and whether they trained it, like us, twice the context length. There's a lot of factors there, but yeah, I definitely would say don't take the number that's on the paper as the number you should use.
Okay, awesome. Well, thank you both for joining us today. Lucas, maybe you can tell everybody a little bit about where they should go today to download the model and the kind of vibes they're going to get when they do, and when they should be picking it up in the future for everybody that's going to watch this.
Absolutely, yeah. huggingface.com/rc-AI is where we kind of live in our open weight releases. And you can go to our website, rc.ai or chat.rc.ai to play with Mini. You can also use it on OpenRouter for super cheap, but also there's a free tier. Yeah, Mini is a reasoner. It's really, really good, though. I mean, the thing that makes me I'm somewhat of a perfectionist, so like I'm always wanting to make these things better. So the more you use it, the more you let us know, the better we can make these in the future. And then Trinity Large coming January 2026. So
on X at Lucas
L Atkins, yeah.
L Atkins, and then at LLM_wizard. Wiz, we look forward to hearing your feedback as the models continue to come out from Arcee before we have our friend Lucas back again. Guys, have a fantastic week at NeurIPS. It's been a pleasure having you today on YouTube.
Thank you, Greg.
Thanks, guys. Yes.
All right. Thanks, everybody, so much for joining us today for another weekly Wednesday YouTube live event. We have a couple more events coming up, and we heard prompt optimization today. I think I'm hearing the call. That might be the one we pull off next week, really covering a little more on the updates on DSPY. If that is, in fact, one of the number one things we need to be doing as AI and agent engineers, maybe we should get on it. In any case, we did send out the AI Engineering Bootcamp Cohort 8 Demo Day playlist in our newsletter yesterday. The folks who worked really hard over the last 10 or 15 weeks to put these together would really love you to check them out and let them know what you think. Otherwise, we do have the next bootcamp cohort coming up in January. If you're interested, you can definitely apply today on Maven, complete the AI Engineer Challenge, and enroll. We may have some deals coming up in the holiday season, so get your challenge done early so you're ready to rock on those. We just kicked off the next cohort of the AI Engineer On-Ramp, so shout out to everybody who's joining us in there as well. And that's all we got for you today, guys. We'll give you some feedback next week on what we saw from NeurIPS, on what he thought was interesting, and look for that prompt optimization event coming up soon. Until then, and until next time, keep building, shipping, and sharing. We and the folks at Arcee will certainly keep doing the same. Have a great week, everybody. See you soon.